Okay, now we have this chemical equation for chemical equation, ya, untuk persamaan kimia. So persamaan kimia contohnya dia akan bagi soalan macam ni. Tetapi apabila kita dah belajar dengan lebih lanjut, producing zinc sulfate ini tidak perlu ada, di mana kita harus fikir sendiri what would be the product. Jadi maksud kita kena tahu apakah hasilnya nanti. So contoh soalan ni dia dah bagi soalan sekali, betul? Dia dah bagi hasil sekali. Jadi sekarang dia dah beritahu bahawa zinc bertindak balas dengan cuprum 2 sulfide. So copper reacts with copper to zinc reacts with copper to sulfate, producing zinc sulfate and copper. So zinc bertindak balas dengan cuprum 2 sulfide menghasilkan zinc sulfide dan cuprum, betul? Jadi zinc, what is the chemical formula ataupun atomic formula untuk zinc? So it will be Zn. Zn ialah dia punya atomic formula. Bertindak balas dengan, when it says react, bila perkataan bertindak balas, kita akan lambang dia sebagai tanda campur, which is a plus sign. So copper to sulfate. Okay, now why is copper there is a bracket of 2 Roman? So because copper is a transition element. Kerana cuprum ialah unsur peralihan, jadi charge kepada ion unsur peralihan akan terdapat di dalam bracketnya. Jadi kita tahu copper ialah Cu, betul? We know that for copper it is Cu, the symbol is Cu. But since in the bracket it is 2, therefore we know that it is Cu2+. So the bracket in Roman, the Roman number in bracket for copper, since it is a transition element, that shows the charge of its ion. Jadi kalaulah tiba-tiba cuprum dalam bracket tu 1, jadi ion cuprum itu ialah 1+. So sekarang dia ialah Cu2+, sebab di dalam bracket itu ialah bilangan nombor 2 dalam huruf Roman. So bila Cu2+, sulfate kita dah bincang tadi, sulfate ialah SO42 negatif. Macam mana nak stabilkan? 2 tambah negatif 2, kosong. So dia akan jadi 1, 1, betul? So ini perlukan 1, ini perlukan 1. So dia akan jadi CuSO4. Okay, dan dia akan kata hasilnya ialah zinc sulfide. So zinc, kita tahu juga zinc ialah Zn2+, sulfate ialah SO4. So it will give you ZnSO4 plus Cu. So this is a chemical equation. Jadi inilah persamaan kimia di mana zinc bertindak balas dengan cuprum 2 sulfide menghasilkan zinc sulfide. Kenapa zinc sulfide macam ni? Sebab zinc ialah 2+, sulfide ialah SO42 negatif. Jadi gabung, kita perlukan 1 zinc dan 1 sulfide bercampur menjadi zinc sulfide, betul? Dan juga menghasilkan cuprum. Okey. Bila kita sudah ada persamaan kimia sebegini, when we already have or established this chemical equation, we need to determine whether is this equation stable ataupun balance or not stable, balance. So adakah ini dah seimbang? So sekarang kita kira dekat sini. Kita ada 1 Zn, betul? Kita ada 1 Cu dan kita ada 1 SO4. On the left hand side, which is what we call as the reactant group, bahan bertindak balas. On the left hand side, which is bahan yang bertindak balas, kita kira ada 1 Zn, ada 1 Cu, ada 1 SO4, betul? On the right hand side, belah kanan, kita tengok juga ini kita panggil sebagai produk ataupun geng hasil. Itu tadi geng bahan bertindak balas, ini geng hasil. So geng hasil dia ada berapa? Ada 1 Zn juga, ada 1 SO4 juga, dan ada 1 Cu juga. Jadi stable tak? Balance tak? 1 Zn, 1 Zn, 1 Cu, 1 Cu, 1 SO4, 1 SO4. Oleh itu persamaan ini telah seimbang. Inilah persamaan yang kita mahukan. Okey? Jadi lepas ini saya akan bagi contoh persamaan yang tidak seimbang dan kita perlu seimbangkan macam mana. Okey? Okay, jadi ini adalah contoh satu lagi tidak balas yang akan berlaku. So this is another example of reaction. So aluminium reacts, aluminium bertindak balas dengan oxygen gas, dengan gas oksigen. So aluminium reacts with oxygen gas producing aluminium oxide. So kita sudah ada, what is it called? Kita ada bahan bertindak balas. We already have the reactant, which is aluminium and oxygen gas, and we already have the product, which is aluminium oxide. So aluminium react with oxygen gas. Oxygen in form of gas is never monoatomic, it is always diatomic, which is O2. It is never just O. The only monoatomic gas that exists in the world is just from group 18, which is the noble gases, which is helium, argon, neon, radon, krypton, and xenon. Okay, so for oxygen gas, it is O2. And the product would be aluminium oxide. Remember we did just now, aluminium oxide is Al2O3. So now we have Al, we have O2, we have Al2O3. So now look on the left hand side. We only have, okay, here we only have one Al and two oxygen. So kita ada satu Al dan dua oksigen di belah kiri, di belah geng bahan bertindak balas. Dekat geng hasil, at the product, we already have 2 Al and 3 oxygen. How to stable them? Tak stable lagi. So macam mana kita nak stablekan? So first kita kena fikir macam mana nak jadikan Al ni sekata dan macam mana nak jadikan O2 ni sekata. Okay, so how to make this O be equal and Al be equal as well? So I would suggest, what if I put 2 here? Why do I put 2 here? Because you see, Al2, when we times 2, so the total everything would times by 2. So you will get 4 Al and 6 O. Why do I times here by 2? Why don't I times everything here by whatever number? Because this is the most complex. And when I times it by 2, I've already changed this odd number to even number. Jadi sekarang, kenapa saya darab sini dengan 2 dan saya tak darab apa-apa dekat sini? Sebab kalau saya darab apa-apa kat sini, saya akan buat balik. Meaning that I need to redo and redo. For example, if I put here 2, and it would be a bit messy. So why I put 2 here? First, because you see, we have this 1. 1 can be multiplied by any number to stabilize, right? Kita boleh darab dengan apa-apa nombor dekat depan ni kalau kita nak stabilkan. Sebab tak ada masalah. Sebab Al ni memang 1. O ni memang 2. Jadi O ni kalau contoh saya letak 1 ke, saya letak 2 ke, saya letak 3, nilai oksigen akan sentiasa genap. Tetapi dekat sini ganjil. Jadi untuk genapkan, saya kena darab dengan nombor yang, kalau saya daripada 3 nak genapkan, saya kena darab dengan nombor yang genap. So saya pilih 2 dulu untuk start. So bila saya letak 2, saya dah darab semua dengan 2 kan. So dia akan jadi 4 aluminium dan 6 oksigen. Jadi bila ada 6 oksigen, boleh tak saya stabilkan kat sini? Saya dah boleh stabilkan kat sini, saya letak sini 3. So ini sudah darab 3, jadi 6 oksigen. Sama atau tidak? Sama. So when I put here 3 to balance out with this would be 3O2, 3 oxygen. So 3O2, it would be 6 oxygen here. And this would balance out this part. So now we have 4 Al. Kita dah ada 4 Al here. So this we have 1 Al. How to make it 4? We just simply multiply with 4. So just put a 4 here. Therefore, the equation, the final equation is 4 Al plus 3 O2 will be 2 Al2O3. This is the final balance equation. Hopefully you guys understand. Okay, so next we are going to do some calculation from what we have here. How to make use this complete balance equation. Stay tuned. Okay, so guys, in exam you would expect this kind of question. So this question, okay, dalam peperiksaan sebenar, inilah contoh-contoh soalan yang boleh ditanya. Dan anda perlu mahir untuk tahu bagaimana untuk hasilkan persamaan kimia, balancekan ataupun seimbangkan persamaan kimia dan kira menggunakan persamaan kimia. Okey. Jadi sekarang ini akan jadi agak detail. So tolong fokus. So be focused here. It's going to be a bit tricky and a bit meticulous. Okay, now iron trioxide is heated with hydrogen gas to produce iron metal. So we know that apa? So iron trioxide, ferrum 3 oksida bertindak balas ataupun dibakar dengan gas hidrogen untuk menghasilkan logam ferrum. Okey, sekarang jisim yang dia bagi ialah logam ferrum dan dia tanya apakah jisim logam oksida tersebut. So, this metal oxide, what does it show? What is the metal oxide that we're talking about? The metal oxide that we're talking about is basically the iron trioxide. So, in another way, soalan ini minta apakah jisim logam oksida iaitu ferrum 3 oksida kalau setelah dibakar dengan hydrogen gas menghasilkan 5.6 gram logam ferrum. Itu yang ditanya. So sekarang in the question is asking what is the mass of the metal oxide, which is the iron trioxide, if after reacting with hydrogen gas produces iron metal as much as 5.6 gram. So the first things first, we need to form the equation. So we know ferrum 3, like I said, transition element in bracket is 3, so Fe3 plus, oxide is O2 negative, so this is going to be Fe2O3, right? Because this is going to be 3, this is going to be 2, so 2, 3, so Fe2O3. Got it? Okay, now we know that for iron 3 oxide, so iron 3 oxide, I repeat here, Fe3 plus and O2 negative, so the charge is 3, the charge is 2, we cross, so this is 2, this is 3. How many Fe is needed? Fe2. How many oxygen is needed? O3. So this is ferrum oxide, ferrum 3 oxide, sorry. So Fe2O3 react with hydrogen gas. Like I said, the only monoatomic is the group 18, which is the inert gas. The rest is diatomic. So react with hydrogen gas. So react with hydrogen gas, you know that the final result you will get an iron metal. Now, this is the question where you need to think a bit more and be a bit smart. So now, you have an oxide here, a metal oxide. Kita dah ada logam oksida dekat sini. Kita tindak balaskan dia dengan hydrogen, kita dapat ferrum, kita dapat logam. So, when the ferrum goes here, apa berlaku dekat oksigen dengan H ni? Apa bahan yang ada? Hydrogen dan oksigen. So, now, we already have the oxide reacting with the hydrogen. And we know that one of the product is the metal atom, is the iron metal itself. So this iron metal is already taken. So now we are left with oxygen and hydrogen. So we need to think what substance can be produced when we have a hydrogen, when we have hydrogens and oxygen. So H2O would be the most stable and the most known to be produced. So we have H2O, right? So without being said in the question, this is the things that you need to understand. So, it is being said that you already going to produce the metal, therefore this metal is no more going to interfere with these two at the end, because the ferrum is already going to just be into metal. So maksudnya ferrum ini akan kekal menjadi logam, selebihnya akan menghasilkan sesuatu yang lain. Jadi kita kena tahulah apa yang dia akan hasilkan tu. So ada hidrogen, ada oksigen, hidrogen dan oksigen, benda yang paling stabil yang boleh dihasilkan ialah air. So akan menjadi air. Okay, now adakah dah stable? Sekarang dekat sini we have 2 ferrum, we have 3 oxygen, we have 2 hydrogen. Here we have 1 ferrum, we have 2 hydrogen and we have 1 oxygen. So how to stable this? kita ada 3 oksigen kat sini. So, kalaulah sini saya darabkan dengan 3, so if I am multiplying this by 3 to become 3 oxygen, I need to multiply this by 3 as well because I am multiplying everything by 3. Right? Kalaulah saya nak oksigen ni 3, saya kena darab sini semua. Saya kena darab air sebab air berbentuk molekul. Jadi, hidrogen dan oksigen itu bergabung. Jadi, kalau saya nak banyak oksigen, saya nak gandakan oksigen, hidrogen turut digandakan sekali. So, if I wanted to multiply the oxygen from 1 into 3, as I am multiplying or as I am, what we call it, making it double or triple, as I am multiplying it, like I said, I need to multiply the hydrogen as well because they exist as a molecule. How many times I want to, basically how many I want to add oxygen to, that is also the amount of hydrogen that I'm going to add because they are coexisting together in this molecule. So when I am multiplying this oxygen by 3 to get 3 oxygen to stable with this, I also need to multiply the hydrogen by 3 as well as they exist together. So 3, we are multiplying the water by 3. So you will get 6 hydrogen. So how are we going to balance this and this? So ferrum, it's quite straightforward because sebab ferrum dekat sini memang satu. Nak jadikan 2, darab saja 2. Betul? So ferrum is very straightforward because you only have 1 ferrum here. You just times it by 2. Now, the problem is solved for ferrum and the problem is solved for oxygen. The problem is yet to solve for hydrogen because here you have 6 hydrogen, here you have 2. So you times this by 3. So in the end, we need to think. Does this we times by anything? Ada tak kita darab apa-apa? Tak ada. So Fe2O3 stays. Plus, how many that we are timesing it? So we are multiplying it by 3. So 3H2O. Right? 2. How many ferrum? There's 2 ferrum. So 2 Fe. And how many water? Plus 3H2O. So, now we are going to calculate. Fe2, 2 ferrum, balance. O3, balance. H6, H ada 6, so there's 6H here, there's 6H here, balanced. Okay, now is the real question. Is this really balanced though? So is this really balanced? Oh, sorry, there's no O here. Okay, is this really balanced though? So now, ferrum is 2, hydrogen is 6, oxygen is 3, oxygen is 3. So this is balanced. Okay, so this is the complete, balanced and perfect equation for the calculation. So okay, because I'm going to erase this and just leave us with this for further calculation. Hopefully, if you guys still don't understand, you guys can pause now and try to look at how I balance this. Any question, do comment below. I would gladly to answer any other questions that you would like to ask. Okay, so let us go and try to calculate this. So now, the final one is Fe2O3 plus 3H2 becomes 2Fe plus 3H2O. Fe. Okay, done. So now, when we have this kind of equation, how are we going to calculate? Okay, do you see numbers in front? Now I'm talking about the numbers in front, not at the back. Okay, the numbers at the back of each symbol is the number of atoms in the compound. The number in front of the atom or of the symbol is basically the number of molecule being used in experiment or in the reaction. So now, it is fair to say if I have one particle of Fe2O3, I react it with 3 particles of hydrogen gas, I will get 2 particles of Fe and 3 particles of H2O. Or in another clearer way, ataupun nak lebih jelas, satu sebatian ferrum 3 oksida kena bertindak balas dengan 3 molekul hydrogen gas akan mendapatkan 2 atom ferrum akan mendapatkan 2 atom ferrum dan 3 molekul air. I repeat in English, if I have one ferrum 3 oxide compound, I would have to react it with 3 molecule of hydrogen gas to produce 2 atom of ferrum and 3 molecule of water. Okay, meaning that the ratio is 1 to 3 to 2 to 3. Right? So the ratio is 1 of these react with 3 of these, producing 2 of this and producing 3 of this, right? So this is the ratio. Before that, why do I need the ratio? This is what we call, starting from here, this is what we call as the stoichiometry calculation. So what is stoichiometric calculation? Is when you use the ratio produced from a balanced equation. The word is balanced. It must be balanced. If it's not balanced, you cannot do this equation properly and the calculation perfectly. So it must be balanced. So now the equation is balanced. So the ratio produced by each of the reactant and the product produced. Jadi maksudnya nisbah yang terhasil apabila persamaan ni sudah seimbang, nisbah yang terhasil itu akan digunakan dalam pengiraan stoichiometry. Okey, stoichiometry itu apabila kita nak cuba kaitkan antara ini dan ini dan sebagainya lah. Maksudnya kita nak kaitkan bahan bertindak balas dengan bahan yang terhasil. So sekarang maklumat yang kita ada, kita sudah ada mass, kita sudah ada jisim iron metal. So we already have the mass of the metal iron. We already have the mass of metal iron, which is 5.6. So can we find the mole of metal iron, of the ferrum iron? Yes, we can. So 5.6 divided by 56. It is said here, the RAM. So dah tunjuk kat sini. Jisim relatif atomik untuk ferrum ialah 56. Jadi kalau jisim logam ferrum ialah 5.6 gram, mol untuk logam ferrum ialah 5.6 bahagi 56. So, kita akan dapat 0.1 mol. Okay, so we are going to get 0.1 mol. So, sekarang kita nak dapatkan apa? So, mass yang kita nak ialah mass metal oxide, iaitu ferrum 3 oksida. Betul? So, the mass that we want to find is the mass of ferrum 3 oxide. Jadi, we are going to circle the things that we need. Now, kita ada iron metal. So, this. And kita nak cari, we are finding the mass of metal oxide. Can you see the ratio? So, Fe2O3, we need 1, producing 2Fe. 2. So the ratio is 1 to 2. Right? Now, this is, so it is also fair to say, selain daripada yang tadi saya cakap, satu compound ini, tiga molekul ini hasilkan 2 atom ini dan 3 molekul ini, I can also say macam ni. Kita pun boleh cakap bahawa kalaulah saya ada 1 mol ferrum 3 oksida, saya bertindak balas dengan 3 mol hydrogen gas menghasilkan 2 mol logam ferrum dan 3 mol air. So if I have 1 mol of ferrum 3 oxide, I shall react it with 3 moles of hydrogen gas producing 2 moles of ferrum atom of ferrum metal, and also 3 moles of water are going to produce as well. So now, since I've already got the mole of ferrum, which is 0.1, so 1 mole, this is where I'm going to compare. So 1 mole of Fe2O3 will produce 2 mole of ferrum metal. Right? So 1 mole of Fe2O3 will produce 2 mole of ferrum metal. Therefore, if I'm having or I am producing 0.1 mole of ferrum atom, if I'm having 0.1 mole of ferrum atom, how many moles of ferrum trioxide that I need? So since this is half of this, so kalaulah kita dapat kita nak hasilkan 0.1 mol, berapa banyak ferrum 3 oksida yang kita dapat? Kalau kita tengok di sini 1 mol hasilkan 2, kalau 0.1 mesti asalnya daripada 0.05 mol. So meaning that, tengok betul-betul if 1 mole of ferrum 3, so 1 mole of ferrum 3 oxide is required to produce 2 mole of ferrum metal. Therefore, 0.05 mole of ferrum 3 oxide is required to produce 0.1 mole of ferrum. Clear? Dalam bahasa Melayu saya ulang, kalaulah 1 mole ferrum 3 oksida diperlukan untuk menghasilkan 2 mole logam ferrum, oleh itu 0.05 mole ferrum 3 oksida perlu untuk hasilkan 0.1 mol logam ferrum. So sekarang, adakah kita dah dapat mol untuk ferrum oksida? Dah dapat. So sekarang, mol of Fe2O3. The mole of Fe2O3 is 0.05. What is the mass? So how to find mass from mole? We multiply by the molar mass. So mass of Fe2O3 would be 0.05 times by Fe2 kan? So 2 times 56 plus 3 times 16. So how much are we going to get? So 0.05 times by this, the answer that we're going to get, and the final, this is the mass of Fe2O3 that we're going to get, which supposedly would give you 8 grams. Got it? So meaning that the most important part is, this is the 4C. The first C is the chemical equation. The second C is calculation of either mole of information yang dia dah bagi. So meaning that yang pertama, persamaan kimia mesti tepat dan seimbang. Yang kedua, pengiraan mol untuk apa-apa bahan yang dia dah bagi. Yang ketiga, perbandingan. Dan yang keempat, kiralah apa yang dia nak. Dalam kes ini mass, mungkin boleh jadi volume, mungkin boleh jadi mol, mungkin boleh jadi bilangan zarah. So itu, pengiraan itu kita boleh tengok di video yang sebelum ini. Okay, so like I said, I repeat in English. So 4C, like I said in English, we use 4C. So first C, chemical equation must be balanced and perfect and correct. The second one is the calculation of mole of either one of the reactant or either one of the product, depending on what information has been given to you in the question. And from that, we compare. So the third C is compare. So the ratio to ratio. And after we compare, we calculate whatever information that they want. So in this case, it is the mass. It could also be volume. It could also be the number of particles. And it could be also the mass of, like I said, the mass of volume or the number of particles. So how to calculate this and how to calculate this. If some of you guys are quite unsure, you guys can check my previous video. We talk about how to calculate this. So this sums up the important part of this chapter. So remember, try to practice more of your chemical formula. Try to practice more in balancing equation, and try to practice this kind of question. This question usually would give you 3 marks. The first mark, basically this is going to be in the first question, the first part of the question. The second part is going to be this. So this calculation is going to give you 3 marks. ni selalunya akan jadi 3 markah, pengiraan mol ini 1 markah, perbandingan ini 1 markah, dan pengiraan semula untuk bahan yang lain akan mendapat 1 lagi markah. So this is going to be 3 marks. So hopefully you guys enjoyed this class. Do comment below if being bilingual in this video is confusing. If it is, I'm sorry. I'll try to revert back to my old kind of video, which is going to talk more in English. Ataupun kalau anda berminat dan lebih faham kalau saya berbahasa Melayu dan bahasa Inggeris, saya akan teruskan juga. Jadi hopefully you like this video, subscribe and share to all your friends. Hopefully they like it. See you in the next video.